Okay, let's just do, close them up real quick. I want to do just a very brief review, go through just an example of each type, and then let you work on this stuff. It's been a few days. So, we're talking with these two sections deal with solving absolute value equations and inequalities. Go ahead and click them all the way close, please. They deal with, you know, we're gonna go back to this absolute value parent graph a lot. Absolute value of x, we know it's a v, right leg, slope of 1, left leg, slope of -1. And here's really the three things you gotta remember, really simple. So we have to remember that if we ever start off with something of the form, the absolute value of u, where u is, u could be anything. Could be, 2x minus 7, or, could be a function of x. The absolute value of something is equal to a. Remember that we can't do normal algebra with absolute value functions. We've got to get rid of them, right? We've got to make a trade, essentially. We want to make a trade. This equation, this absolute value equation, and by that I just mean an equation where we have an absolute value in it. We want to trade that for two regular equations that we know how to deal with, both of which do not have absolute values. And it's pretty simple. We just know that once we isolate the absolute value, so we get the absolute value of something is equal to a number, then the two equations are obvious. Two equations are going to be either what's inside the absolute values is equal to the number, or it's equal to the opposite of the number, right? And it makes sense that both of those could work, because if we started off, for example, with, like let's say we had something like -7 in there. Right? Well, what's the absolute value of -7? 7, right? The absolute value is going to make it positive by multiplying by -1. If we started off with something that was already positive, then the absolute value wouldn't need to do anything, right? Let me remind you guys, now listen, we've had a few days here, but I do not want to see earbuds out. If you got earbuds in, those have to go away, or I'm going to start taking those, okay? I know you might think you can do it, but you can't. You might think you're able to multitask like that, but it's not an option for me. Okay, if we have an absolute value inequality where we have the absolute value of something is less than or equal to some number, as opposed to the absolute value of something is greater than or equal to a number. What are the trades we make there? These pictures help you remember that, right? If we want to know when the absolute value function is less than a number, remember that when we're talking about a function, about the output of a function, which is a y value, greater than is up, is vertically up, less than is vertically down, isn't it? Right? So we want everything below the intersection of the line and the v, right? So what's that mean? We want everything below y equals a. Remember, this is just the line y equals a. Let's write that in there. Right, so there's that horizontal line at y equals a. If we want all the part of the function less than that, we want the part below, well, that's just going to be the part of the v between the intersections, isn't it? Right? Does that make sense? We're just capturing the part of the v between -a and +a. Right? So the trade we make then, whenever we start off with an absolute value of something is less than or below a line, right, where the v is below the line, we're going to end up with this type of a compound inequality. Those are the two inequalities we get. We get u has to be greater than or equal to -a, and less than or equal to +a, right? And you just need to remember, and hopefully this picture helps. If you stare at this picture and you think about it a little bit, I think you'll connect the dots here, and it'll make sense in the future why you do it this way. But initially, I mean, if that's not totally clear, and you need to spend some time with the picture first, just memorize it for now. You know that if you have an absolute value that is less than or equal to something, it always gives you the and compound inequality. Compare that to if you've got an absolute value function that's greater than a, then what's that going to give us? We want the part of the half plane now that's going to be above the line y equals a. Well, if we want the part above, That's gonna be everything to the left of that intersection and everything to the right of that intersection, right? So we end up getting these two separate pieces. That's an OR inequality, isn't it? Compound OR inequality, like the ORs on a boat, right? So we make the connection then, and you can just remember it if you want to. I think you're better off, if you can manage, I think you're better off studying that picture. So I'll put the notes up. I think they're already up. But I'll put this one up right away so it's there for you on Moodle. We know that if you start off with one like this, where the inequality sign is a greater than, the absolute value function is greater than A, then you're going to get those two inequalities. A compound, the two inequalities, we call it a compound inequality, meaning both taken together. Either what's inside is less than negative A or it's greater than positive A. It's not in between, it's the extremes, right? Okay, let's try a couple quick examples. So what about something like this? Hardest one I could give you. Absolute value equation. What do we have to do to solve this thing? Subtract 2 and divide by 4, because the first thing we got to do is isolate the absolute value, right? So we're going to subtract 2. Got 2, 16, then divide by 4, right? If we divide by 4, what's that going to give us? 54, there we go. So those two steps combined, we just isolate the absolute value function, right? Then what? Once we isolate the absolute value, what's my trick? If I have the absolute value of something, call it U, is equal to 54, remember, I can't do anything else, right? If I don't make a change here, I've got these absolute value bars. I can't do algebra with absolute value bars. It's really hard to do, right? So we're going to make our trade. We got to get rid of the absolute value bars. What's the trade? Say it again. No, I can't do that. Can't do that. Because that's making changes inside the, I can't touch anything inside the absolute value bars. Good. There you go. So whatever's inside, and it's off limits, right? Whatever's inside the absolute value bars, we can't change. Whatever's inside, we set equal to 54 or negative 54, right? So either negative 3x plus 24 equals negative 54, or negative 3x plus 24 equals positive 54. And there's a, there's a real strong motivation to try to get rid of that negative because it's inside an absolute value, right? An absolute, but remember, we can't do that. Can't do that, right? Because we're dealing with a variable there, and it's going to change the values of the variable that make this true if I make that a positive 3 instead of a negative 3, right? So we can't touch that. And then we would just solve those two equations, which are pretty easy to do, right? And both of those, just going to subtract 24 and divide by negative 3, and we're done, right? You guys can do that. I won't even take your time up on that. You can do that part. But the important thing is we've got these two equations that we then have to solve. But they're easy ones, right? Okay, so how about one like that? We gotta isolate the absolute value, right? So we're gonna isolate the absolute value, which means what two steps in order? Good, subtract 6. And then divide by negative 4. So what's that gonna give me? If I divide, there you go, 12. isolate the absolute value. Now, here's the part, but I put in the equation there, I was wrong, wasn't it? It's not supposed to be an equation. What am I doing? Okay. It was a less than or equal to, right? But then when I divide by a negative, yeah, that's gonna flip it around, isn't it? Right, so I'm gonna end up getting a greater than or equal to. Okay, so we isolated the absolute value. Now we gotta do our trick though. We gotta make our trade. What's the trade we make when we have the absolute value of pan? We don't even care at this point. You can mess with anything inside the absolute values. We get the absolute value of something is greater than or equal to a number. What's the trade we make? Is that an and or an or? If it's greater than, that's the one where it's above, right? It's above the line, so it's got to be an or, doesn't it? Right? So we end up with whatever's inside either has to be really negative, it's got to be less than or equal to negative 12, or whatever's inside has to be really positive. It's got to either be way out there or it's got to be way out there, right, to the right. So it's 4x minus 4 now has to be greater than or equal to positive 12. And I just solved both of those, but that's easy. You just can do that part, right? It's not a big deal. Yes, sir?
Positive 12 or positive 14?
Should have been 12, you're right. I don't know why I put 14. I don't know what I was doing. There you go. And in both cases, I'm just gonna add 4 and divide by 4, right? So if I were to, let's just solve one of these two. If I add 4, I get negative 8, right? And then if I divide by 4, there's one of my answers. X is greater than or equal to negative 2. And then over here, I'm gonna get 4, whatever that gives me, right? I want to get going, let you guys work though, so one more. What about this one? Subtract 12. Good. Okay, so we're going to subtract 12, so I get negative 3 times the absolute value of negative 2x plus 6 is greater than negative 84. Divide each side through by negative 3, okay, but I'm dividing by a negative, so I've got to flip the sign. Good. What do I get? Over here I just get the absolute value of negative 2x plus 6. This side I'm going to get negative over negative is positive. What is that, 28? Okay? Make sense? All right, can I get rid of that negative sign? I cannot, you're right. I can't touch anything inside the absolute value bars, right? But I can make a trade. So if I have the absolute value of pan is less than a number and or compound inequality. Over. That means we want the part that's going to be below. Less than means below the line, right? So it's going to be this picture, isn't it? It can be that picture, right? So we want the part below. So that's the part of the V that goes starting there, going up to there, right? So so what X value? If I squeeze that part onto the X-axis, don't I just get that part right there? Mm-hmm. So that's and, right? It's bounded on the left and the right, okay? So I make the trade. Whatever's inside the absolute value bars has to be greater than negative 28 and less than positive 28. And then all I have to do, and I want to finish this one because there's one part here I want to make sure you guys get. Now I just isolate X. Say it again. Okay, subtract 6 everywhere. Good. Okay, so that's gonna give us, if I subtract 6, I get my negative 2x, my negative 34, and my positive 22. And then we divide everything you said by negative 2. Okay, that's good, but, yeah, I divided by a negative, didn't I? So all those have to flip around. And what do we end up with then? So we get negative 11x, and then negative over negative is positive. So that's my answer, but it's written backwards, right? Doesn't that look funny? That doesn't look right, does it? We don't say x is less than 17 and greater than negative 11. When we write a compound inequality like this, you might remember when we did these at the start of the year, when we got one like this, we always had to take the whole thing and flip it around, right? Pretend we write this on a glass slide, a piece of glass, and then we're just gonna do that with it, right? We're gonna flip it around. So the negative 11 goes on the left and the 17 goes on the right, because we want to represent this like a line segment on a number line, right? The lesser number goes left and the greater number goes right, just like a number line. So we'll just flip the whole thing around. So the x stays in the middle, and then this part over here is going to get flipped over to that part. So we get a negative 11. X is greater than negative 11 is on the left, and x is less than 17 is on the right. Now that looks better, doesn't it, right? If I were to graph this solution, thank you. If I were to graph this solution, then it makes sense, doesn't it? Now I've got one boundary is at negative 11, one is at positive 17, and we're just graphing everything in between, right? Make sense? Okay, go, good work.
Sorry.
Yep.
If we put like the first answer in Google, would it still work?
No, it'd be wrong.
Would it be wrong?
Yeah, it'd probably give you like half credit or something.